going to make a second map now, and this time we're going to look at some of the options for thematic choropleth mapping. So I'm going to close the map that I've got. This brings me back to my catalog pane. And I want to go over to Insert, New Map, and we're going to choose New Map. Again, by default, it's going to be named Map, and we can change that actually from the map view as well, not just from the catalog view. You can right-click under Contents and Drawing Order, and choose Properties. And here, we can call this Example 2 Population Map. Choose OK. Go back to the catalog view briefly. We're going to find our data folder, and we're going to choose the STL demographics neighborhoods data. Right-click on that shapefile and choose Add to Example 2 Population Map. What we have here are each of the neighborhoods in St. Louis minus neighborhoods that are actually large parks. So there are 4 large parks in North St. Louis. 3 are actually parks. 1 here are the 2 cemeteries in North St. Louis. Forest Park, Tower Grove Park in the Missouri Botanical Gardens, and then Carondelet Park in South City, as well as the park along the River Des Peres. First type of map we want to work with here is just a qualitative map showing the neighborhoods themselves. We can do that by going over to the symbology pane. If that's not open for whatever reason, you can right-click on the layer you're interested in and choose symbology. Under primary symbology, there's this pull-down menu where it says single symbol. We can select that and then select unique values. By default, this gravitates to the neighborhood numbers field and presents us with a pastel-like color scheme. We can pull that down and we can see a number of different options. I'm going to select dark glazes, which is a color brewer option. And then I'm going to click on Add Unlisted Values. There is a numeric value for each of the neighborhoods in St. Louis, just based on number. We're going to select all of the values and click OK. This gives us a qualitative map of each of the neighborhoods in St. Louis. They're symbolized with different hues so that it's easier to distinguish between these different areas. If you don't like this color scheme, there are others as well. We could, for example, scroll down and pick the purple blues color scheme with an alternative way to symbolize these different features. So this is for making a qualitative map. If we want to map a quantitative value that's stored in these data, we would change from unique values to any of these options under symbolize your layer by quantity. So we have the option for graduated colors, graduated symbols, proportional symbols, or dot density. I'm going to start with graduated colors. It's going to default to the first numeric variable in the table, which in this case is neighborhood number, not a particularly interesting value to select. And we've got 3 variables we could potentially map: the population of St. Louis in 1950, the population of St. Louis in 2017, and population change between those 2 years. So I'm going to start with population 1950. Now these are population counts. They're the estimated number of people living in each of the neighborhoods in 1950. If we want to change our color ramp, we can use this pull down. These options here are Viridis color palettes. If we scroll down a little bit further, we get classed and continuous color ramps from Color Brewer as well. So we have a number of choices, all of which are potentially good options for our data. I'll start with a Viridis color ramp. I like the magma ramp in particular. So the lowest, least populated areas are going to be darkest. The most highly populated areas are going to be the brightest color. Now remember, we don't want to map just by population count. We want to normalize the data. And so if we pull down our normalization menu, we can select area. This is the number of square meters covered by each neighborhood. And that changes our map from a population count map to a population density map. And so we can see the densest neighborhoods are those just north and along Delmar and just south of downtown. If you don't like this color scheme, it's as easy to change as pulling down the color scheme menu, choosing a different one. We could try the Inferno palette, another Viridis palette, or the Civitas palette, which I think for 5 classes, this palette looks the best to me. Another option is to pick from Color Brewer. We can try the blue to purple 5 class scheme. And this very nicely accents the darkest areas on the map. The brightest color are going to be the areas with the highest population density. If we want to change how we're symbolizing these data, we could switch to, for example, using graduated symbols. And we're going to need to make the same changes over again. So we'll select neighborhood number, change that to population 50. We want to make sure we're normalizing based on area. To choose a different hue, we would click on the template, and that will get us to a color picker to select from. I'm going to select Cretan Blue, choose Apply. We can use the back button to return to the symbology pane. And there we have a graduated symbol map. Where the larger the circle is, the larger the population density. Last, I want to try a dot density map. I'm going to start by selecting the reds as my option. This time I'm going to choose the population 17 value. And there we have a dot density map for the 2017 population for the city of St. Louis. We've covered 2 major things. We've talked about how to make custom changes to the hues that are selected for individual features, and then a number of ways to change the symbology for mapping a quantitative variable. The lab this week will put both of those skills to the test, mapping areas of Jefferson City.